Hey, Mr. J here with our lesson, hopefully about 10 minutes on section 4.1, slope and equations of parallel lines. This should be a review from your algebra days last spring, maybe last fall, a little earlier in the algebra year. So hopefully this review makes sense to you and that you'll reach out to me if you need some extra help. So we'll jump right into it, if we can here. First, an understanding of parallel lines. And parallel lines are two lines, right, that never cross. They go infinitely, have the same distance apart, which really means they're perpendicular distance apart. So that distance right there is going to be the same here or here. And if these lines go on forever, and they should indicate that they are lines, then they will never intersect. Now the thing that relates this to slope is that the rise and run, so the distance up, that's the vertical piece, and the distance over, the horizontal piece, is the same. So if I group these two things together, I can move them and they should match up if they are parallel. And it doesn't matter where you are, the slopes of lines should always be the same. And I don't think this did group. Right? And I could even change this and it should still match up because it's all proportional in terms of slope. Okay, this part right here, you really should make sure you know. Excuse me, I need the pen here. And let's go to a highlighter. This part right here, the rise over run. Please, at this point, you should know that the rise is the y piece and that should go in the top. That it is subtraction divided by the run. And the run is the horizontal piece. So the horizontal piece and the vertical piece. Rise over run. So this should all be reviewed for you. Let's keep going and maybe do some application of it. So this book will always look for things where we can test it and see. And what they're asking for us to do here, if we look, is to check the slope. Let me get maybe a red line or something that could stand out on this diagram. Indicate which of the points you choose as the first point, which is the second. And so they've put this on a graph, and they want to look at the slope of AB, which is going to be this one, and compare it to CD, which is, let's see if I get this one pretty close, and then I can fine tune it, make sure it's in there. And while they look like they're close or might be parallel, let's go ahead and do the math on it. Now, you can't see the numbers as well over here, but it is 6, 4, and 7, 3. That'll be A, and so that's the x1 and y1. These little subscripts here are just labels. They are not an exponent. It's a label of point A. And B will be 7, 3, and that's x2 and y2. So we'll find the slope of these 2 points. And then CD is the slope of these 2 points. Okay, so I think I have my pen here, and let's do not highlighter now. And so if we want to find the slope of AB, let's do the difference in the y. So I have, so AB, and that's the segment, and I want to find the slope, so I'll put a little m there. The difference in y's will be the 3 minus 4 over the 7 minus 6, and that'll be negative 1 over 1, and that is negative 1. I always like to look and see, does it make sense that it's negative? As we go down and to the right, does it make sense that that slope is negative? I think you'll see that it hopefully does make sense. And so for CD, that'll be 1 minus 3, 1 minus 3. So right now it looks like it might be different, right? 1 minus 3 over 3 minus 1. And that's going to be negative 2 over 2. Oh, it turns out that it is the same. All right, so those slopes are the same, and so we can say that AB, let's segment AB, is parallel to segment CD. All right, I hope that makes sense. I hope the idea of doing slope, and remember it's y2 minus y1 over x2 minus x1. All right, so make sure you do that. You could do y1 minus y2 as long as you did x1 minus x2, because who's to say which is the first point and which is the second point, right? It's up to perspective. So let's go over to another example here. Parallel segments, like parallel lines, have equal slopes and do not intersect. Parallelogram is a four-sided shape or quadrilateral with two pairs of opposite parallel sides. I think we can see that this is not. I think this does look parallel to this. Those are little triangles to indicate that. This is supposed to be like a triangle. But I think we'd see that DC is not parallel to AB. And if we have the coordinates, we could prove this, right? So maybe we'll just check and see without doing the math here. This is down at 7. Oh wait, this is counting by 12, 14, 16. So it looks like D to C. I guess we'll do the math because the box is kind of in between here. You see how C is in between, and it looks like it's actually at 15, and it is. We can see that it is at 15. But let's find the slope of DC. DC will be DC and the slope. And I will do 18 minus 15. And I'll divide that by 8 minus 12. And I'll get 3 over negative 4. And then let's find the slope of A. Now, is it negative? Does it make sense that it's negative? I think it does. It's going down and to the right. In AB, let's find the slope of AB here. And the slope of AB is going to be 5 minus 10 over 7 minus 4 is negative 5 over 3. Right? Is that right? Negative 5. I always like to come back and double check to see if it makes sense. Yep, looks like it. Are these two equal to each other? And I think you'll see they're both negative, yes, but this one's steeper. The AB is steeper in a negative than DC. All right. Let's go to the next page. This is right out of your textbook, so you can always look this up if you need to. Just kind of that idea as a statement, as a property that you could use in a proof. Two non-vertical lines are parallel if and only if. I like to see that biconditional statement. If and only if they have the same slope. Let's keep going. I want to get to, you can skip this page for now, writing equations of parallel lines. So this will be really the major task that I expect you to remember from algebra. So let's take a second to do this, and then we'll do a practice in class. And this is as a decimal. I think I'd rather see it as a fraction. I prefer fractions. 1/4 x minus 5. And it passes through this 0.85. Now we have two ways to do this. I am a fan of point slope form, which is y minus y1 equals m times quantity x minus x1. So if we use that form, let's take it this way, and then I'll show you the other way that you may have learned. If we know the slope is 1/4, and it goes through the 0.85, that means you have a point and a slope, so you can use this form. Replace the 5 for the y1 and the x1 with the 8, so it'll be y minus 15 equals 1/4 x minus 8. And you could be done there, or we could take this all the way to a solution, meaning to distribute this, so we get y minus 15 equals 1/4 x minus 2. Add 15 to both sides. Maybe I need to find a thinner pen. Y equals 1/4 x plus 13. So that's using this thing called point slope form. And you may have learned that and you may not have. If you want to do it another way, let's use mx plus b, okay? Y equals mx plus b. Let's replace what we know. We know the slope is 1/4 because it's parallel. We are looking for the b, so we'll leave that b there. And we do know an x and a y that works here, so the 5 goes here, and the 8 replaces the x. 5 equals 1/4 of 8 is 2 plus b. Okay. Where did I get 15? Excuse me, that wasn't 15. This is supposed to be a 5 over here. This is a nice thing to do, is to do it twice, right? So this was supposed to be y minus 5. I misread this up here. So y minus 5, so we add 5 to both sides, and then we get 3. All right, let's double check over here. Minus 2 minus 2. 3 equals b. So then we come back and write our final answer. Y equals 1/4 x plus 3. Okay, so yeah, I should have had a thinner pen over here. Good thing to check your work, right? And you can always check after you're done by putting things back in. If we take this point and put it back in, 1/4 of 8 would be 2, plus 3 gives us the 5. So, like I tell you, I don't mind making mistakes. I just want you to find your mistakes. I do make mistakes. So I'm going to leave that in the video. And I want to highlight just one more thing before we're done. We have horizontal lines are always y equals, because the y value is always the same. This is y equals 3. And vertical lines, right, are x equals. And these are perpendicular, which we'll talk about in the next section. But if I wanted to do, write a vertical line that goes through the point 2, 7. Well, that means it's vertical, so let's think about it. Vertical will be this, which means they're x equals. Oh, so that needs to be x equals 2. I really recommend you draw little pictures off to the side. If it was, say, a horizontal line that goes through this point, it would be y equals 7. All right, that's our quick lesson for today. Be in touch.